Hello, class. Recorded lecture for section 3.4, college algebra class. And this will be talking about piecewise functions. We're going to skip the first part of this section and just jump right into piecewise functions. So in real world applications, piecewise functions actually occur quite a bit. And I think most of you would be familiar with this idea of a piecewise function. For example, a lot of medicine doses are instructions that are piecewise. And what I mean by that is, say like you were taking Tylenol, for example, and you looked at the bottle and it said, if you weigh between, say, 20 and 80 pounds, take one tablet. And if you weigh, say, between 81 and, say, 200 pounds, two tablets. Greater than 200 pounds, take three tablets. You could see that I haven't gone from zero, but say like you were less than 20 pounds, then you would, sometimes it says consult your doctor. And so what does this mean in the sense of piecewise is that you can see that the weight is split up into four different categories, right? And it will dictate how much of the medicine that you would have to take to get rid of the pain or hopefully feel better. So if you think about this would be 1, 2, 3, and 4. So this Y value here, let's call those tablets. And then the X value here will be the weight. So if we tried to graph this from, say, this is 20. So from 0 to 20 pounds, we're not going to put any recommendation because you have to consult your doctor. So what would happen if we say from 20 to, say this is 80, just putting the key numbers in here, and then this would be 200. And so if you wanted to draw this little piecewise, it would be one tablet here. So that would be 1. And then it would jump from here. It would be 2 tablets up to 200, right? And then 3 tablets would be greater than 200. And you could actually put a line indicating that it goes on forever. And so this is kind of the classic way to introduce a piecewise equation or a piecewise function. And it's described where, remember, the horizontal is the domain. The domain is split into different categories. And you can see that the range or the output of this is tablets. And so to expand on this, of course, we're going to have to put it into more of an equation format. And so just going to jump right in with a reasonably complicated one and walk through a big example. So say like we have an equations that look like this. This would be minus 2x plus 1. And that would be if x is between these numbers, -3 and 1. And then the next question, next one would be number 2, if x equals 1. And then the last part of this would be x squared if x is greater than 1. So there's a variety of different things that we're going to talk about. First thing is, how do you evaluate it? And what I mean by evaluating is that if I give you an x value, what is the output of the function? Or what is the y value? So for example, what would be f of -2? So that implies that x equals -2. So what you do is you you figure out where this fits into one of these 3 categories for x. So I always start at the top and work my way down. So is -2 between -3 and 1? The answer is yes. So you would use the first equation of -2x plus 1, and basically you plug -2 in to see what you get. Wherever you see x, and so that would be -2 times -2 is 4. 4 plus 1 equals 5. So like we did f of 1. Well, f of 1 occurred, that's the breakpoint. You can see that it's the breakpoint here. And if you remember with regards to the greater than, when you're looking for which the equations you use at the breakpoint, which is at 1 and at 3, you're looking for the equal sign. And you see there's no equal sign underneath the less than or greater than. So you would use the middle one, and that would equal 2. So let's take a look at, say, f of 3. So if you look here, 3 is greater than 1. So now we're going to use the third equation, which is x squared. And when you plug in 3, you would get 9. So you could see that it's the same theory when you evaluate these functions, except now you have to worry about which equation that you use, and it's all dependent on this aspect of the domain. Different values of x will dictate those 3 different equations. So if you take a look at a question, say, what is the domain of this function? The range is harder. It's much better to graph it first and then look at it that way, but the domain you could still figure out without graphing. And so what's the smallest value of x? This is kind of how I think about it. So you look on here and it looks like the smallest value is -3. So that would be -3. And does it include -3? The answer is yes. So if you think about it, we're going to start with the bracket at -3. And then it goes all the way up to 1. So if you think about our number line, right? This would be 0. This would be -3. Think about we're starting there and we keep going up. We get to the number 1 and there's an equal sign. So there's no jump, no hole. We keep going and going and going. And so what that would imply that we go all the way to positive infinity. So I think the trickiest part of all this is actually graphing it. And let me kind of show you my strategy when I do this. And so when you graph or sketch a piecewise equation or function, you have to do each one separately. And so what I would start with is the -2x plus 1. And so The main functions or equations that we're going to be graphing will be linear and quadratics. And so this is a linear function, and the function, it has a slope of -2, and the y-intercept is +1. So graph this thing over here. So this would be -3, -2, minus, oops, it's not very good. Let's try that again. So it's better to go this way, right? So we start at -3. So when you plug -3 in for x, you get what for y? So that would be +6, so that would be 7. 1, 2, 3, 4, 5, 6, 7. So that would be right up here. So, and you see that we're going to go all the way down to +1. So let's plug in 0, get another point. When you plug 0 in, we get +1, right? 0. And so when we plug in 0, it's going to be like that. So remember, we're going to come down with a negative slope. That's not a very straight line, but you get it. And so what happens at x equals 1? Well, when you plug x equals 1 in, you're going to get -1, because -2 plus 1 is -1. When you're coming down this way, again, this should be a nice straighter line there. What happens at the end point? Well, at the end point, because there's no equal sign, we indicate that with a circle. And so this would be y equals -1, and we indicate it with a circle that it goes all the way to that point, but it doesn't include that end point. So this would be the graph of the first part, the upper one. What would be the graph of the middle one? Well, the graph of the middle one is just when x equals 1, y equals 2. So that would be this point right here. And then what happens with the bottom one? Well, the way to think about that one is this is now a quadratic. Got x squared here. And it starts at 1, but it doesn't include 1. So when you plug 1 in, 1 times 1, or 1 squared is 1. So in this case, we're going to start right here, but we put a little open circle again because there's no equal sign. And you could see that when you draw a vertical line over those 3 points there with the 2 open circles, it only passes through 1 point. And then when x is 2, y is 4, and when x is 3, y is 9, etc. So x is 2, y is 4, 2, 3, 4. So when you graph this thing, it would start to look like that. So let me pull up a nice looking graph here so you can kind of see what it would look like with this PowerPoint presentation I have here. So there's what the graph would look like if it looked really nice. I kind of wanted to show you the process of walking through those. And so here's the graph. This is the first one, minus 2x plus 1. Here's the point, the middle one, 1, 2. And then here is our quadratic going up. And you can see the 2 open circles that I explained and the closed one with regards to that. So another couple questions that you might be asked is, what are the x and y intercepts for this equation? And so once you have the graph, it's kind of nice because you could see it. And you could see that the y-intercept is x equals 0, y equals 1. It's this point right here. And then the x-intercept's right here. And so it's hard to tell, but you can see the numbers between 0 and 1. And so what equation is dictating the x-intercept? it's the top one. So if you wanted to solve for it, it would be minus 2x plus 1 equals 0 for the x-intercept. So you bring the 2x minus 2x to the other side, you get 2x. And so you had x equals 1/2. So the x-intercept would be 1/2, 0. And that's what's, excuse me, nice about having the graph is that you could see which one of these equations will dictate the x-intercepts. The other thing that we could look at and try to define now is this idea of continuity, or is this graph continuous? When you get into calculus, you're going to learn a closed form technique on how to evaluate if an equation is continuous. And in algebra, we introduced the concept, and it's the concept of when you look at a graph, if you have to pick your pencil up to finish the graph, then the graph is not continuous. So if you see a jump, you see a hole, you see an opening where you have to pick your pencil up, then it's not continuous. And you can see in this case that we have a hole, 2 holes, and a big jump aspect to it. So this one is not continuous. And so hopefully you'll be able to just see that. And the only way that you're going to have, only capabilities that you have to do that now would be to sketch it or graph it. The last thing that we'll talk about is the range. And again, it's the best way to calculate the range of any equation is to graph it. And you can see now we have a graph. So let's see what the range is. So what is the range? Well, what is the smallest value of y? Smallest value of y. So down here, it looks like the smallest value is y equals -1, right? And it's an open circle. So that means that point doesn't include. So it starts at -1, and we have a parentheses there. And you can see what's the biggest value? Oh, it looks like y goes up to, this was 7, right? Over here. But then on the other side, it goes all the way up. This arrow implies we go to infinity. So you take the biggest one, which would be infinity, and again, we'd have an open circle. So this is the largest value of y. And it might be a little bit easier if I show you here on the prettier slide, or prettier graph, excuse me. And when you look at this graph, you could see that again, the lowest value of y is -1. And you could see because of this arrow, the highest value is going to be infinity. So there are other parts of this section that we are not going to do, and we're going to skip, and you have no homework on it as well. So that ends the recorded lecture for section 3.4.